Well, hello. Welcome to our lesson for today. Before you get started, I want you to do a little time, pause your video and do a little warm up. I'd like to see if you can still do the multiplication of scientific notation numbers. And then I want you to find the area of this rectangle. It's kind of important to our understanding of today and the next day. So I'd like to have you do that right now. So pause your video, do these two problems. All right, so let's see how you did. If you did it. Okay, let's see here. First thing we got to do is multiply these two numbers. So 7.9 times 2.3. Let's see, 27 carry the 2, 23 space, 18 carry the 1, 15, and 2 decimal places. So this begins as 18.17 times 10 to the, and now we're going to add 2 plus 11, that makes 13. But since this answer is not scientific, we need to fix it. So if we make this decimal move one smaller, then this has to increase to 14, which means that our answer should be 1.817 times 10 to the 14th. All right. Problem number 2, lots of ways to do this problem. The best way, well, not the best way, a way to do this would be to multiply each area and add those partial products together. Pardon me. So 20 times 10 is 200. 20 by 7 is 140. 3 by 10 is 30. And 3 by 7 is 21. So the total area, 200 plus 140 plus 30 plus 21, is going to be 391. Now you could also multiply, you could do 23 times 17. And if I did that, I'm going to do this in a really weird way. 7 times 3 is 21. 7 times 2, but that's not a 2, that's really a 20. 7 times 20 is 140. This one is a 10. 10 times 3 is 30. And this 10 times 2, 10 times 20 is 200. And if you add that together, you get 391. This is called the partial products method, and it shows you the exact same information as if you were to multiply piece by piece by piece. Or I suppose you could do the old school 23 times 17, which is 21, carry the 2, 14, 15, 16, put a space because nobody knows why they do it. 1 times 3 is 3, 1 times 2 is 2, and you end up with 391. But this method is going to be the important method. Kind of reminds me a little bit of that Punnett square stuff that you learned about genetics in one of your classes when you've been at Britain. So for example, if I have a genetic A and a genetic little a and a genetic B and a genetic big B, then this is A, little a, capital A, little b, capital B, little a, capital B, little b. Something like that. I think they were called Punnett squares. So I'll leave that to the science teachers to remind you about with genetics. But this idea has something to do with what we're going to be doing very soon. All right, moving forward here. So, little reminder, we're going to be using algebra tiles again. This time it'll be all digital though, since you don't have those at home. I just want to remind you about the different pieces. So this tile right here, that tile is called x squared tile. We call it the x squared tile because the x squared tile has the area of it, x times x, is x squared. And this tile right here, this one has a length of x and a width of 1, so the area must be x. So here's my x squared tile. Here's my x tile. And then we had the unit tile, this one right here. This is 1 by 1, so this is my unit tile. Now, there were a couple things that we learned as we were doing this. One, we learned that if you have an x squared tile, you can put an x tile next to it and it lines up nicely. See how the edge matches on the edge right here so perfectly? But you're not allowed to put it this way. If you were to take a bunch of these and start lining them up side by side by side by side, I'm going to try to do the best I can, you can see that this would overlap, right? Even if I were to tuck that in, it's still not going to close it in nicely. And so it's not a whole number distance it hangs over. It just doesn't make it because these are non-commensurable algebra tiles. Now this unit tile could go on the end. So you're not, oh, by the way, let me finish that. You're not allowed to put long sides and short sides together. Can't do that. You can put long side together, or you can put short side, but you cannot do this. If you were to take these tiles and line them up this way, as best you possibly can, everything was looking good until, oh, it hangs over. So long sides can go against long sides, short sides can go against short sides, but they can't go against each other. So keep that in mind. If you get something like this, maybe one over here, I don't know, and then a whole bunch of little unit tiles. And I ask you to write this expression in its simplest form. This would equal x squared plus 4x plus 7. Because there's an x squared, there's 4 x's, and there's 7 little unit tiles. We had this before, it's called a pile of tiles, but this is the simplest way to write it. If we had thrown another tile in here, we would have called this 2x squareds. We're going to use that idea today also. So today we're going to learn how to multiply polynomials. Let me go ahead and hide my video here for you. So we're going to multiply polynomials, and I've gone ahead and made a resource page in your that you have there so that you can go to some links to do all of these problems as links. There's actually 2 resource pages that you have available to you on this lesson today. There's the resource page that looks like this, and it has WR70 where they are making composite rectangles, and it has the homework problems 75 through 80. The WR stood for an old chapter in CPM that we really still like to use, that Mrs. Fink and I really like, or our other teacher. Now, I'm going to go ahead and move over here just for a second. So what you're doing today is the following. You're going to multiply polynomials using algebra tiles to build area models. We're actually going to do an area model of this. And I'm sorry for the bad copy of this. I don't know why it's so bad, but it is. And here's what the problem says. In this semester, we've developed several big ideas. One of these ideas has been the distributive property and multiplication of variables. In the next 2 days, we will expand our understanding of multiplication to include pairs of sums. Use your algebra tiles to construct each of the following rectangles with the specified dimensions. Draw the complete picture of each rectangle on your paper, then write its area as a product and a sum. Label everything as shown in the example below. So you'll be building these on your computers and then drawing this in your notebook and labeling everything. And I will explain what I mean by everything. So they're going to give you what I call a skeleton. This skeleton is telling me to multiply x plus 1 by x plus 4. I know that because I see a length and a width, and they want me to get the area of a rectangle with these particular lengths and widths. So basically, sorry, let me erase this here. Ooh, that's not good. Okay, so basically, you're going to start off with a frame, and that frame is going to help us decide the product of these two pieces. So they're going to give you a length and a width. You're trying to basically fill in an area with this type of picture. It's called a composite rectangle. It's called a composite rectangle because it's drawn very accurately with all of its individual parts labeled. We'll use a generic rectangle tomorrow after this lesson, but for right now we're looking at just a composite rectangle. What are all the parts that it would take to fill in this rectangle? So I'm going to open up the first of my documents here, and we're going to go do this example right here. You have this same document. In the example, it says multiply x plus 1 by x plus 4. Well, every time we multiply a length times a width times a width, length times width is always going to give us the area of a rectangle. So I'm trying to build a rectangle. Now, what we're going to do here is we're going to set up these two expressions up on top, and we're going to build the rectangle that fits in the middle. So I can see right here that I have an x plus 4 and an x plus 1. So I'm going to bring out two x's. X plus 1 I'll put here. X plus 4, 2, 3, and 4 I'll put right here. And my job is to fill in this area with a rectangle whose area is this length times this width. The area. All right, so if I have a long tile and a long tile, see this long edge and this long edge? There's only one shape that is long and has two long edges of length x, and that is this one. This has to fit here. It's the only piece that can go there because remember we said that the long edges can only go against long edges. Oh, it's not going to write for me. There we go. Long edges can go against long edges, and short edges can go against short edges, but not the other way. You can't do it. I mean, you can't do long against short. So if I know that this is long, that's got to be x squared. In here, I have a short and a long edge. The only thing that goes there is this tile. And then I've got another one, and another one, and a fourth one. Now down here, I still have some space. Here is a long edge against a short edge. So I need to turn this. If you double click on it, it'll turn. By the way, if you single click on it, it becomes negative. If you double click, it turns. There we go. And then finally, I need to put pieces in here that are short. See how there's a short edge and a short edge and another short. The only thing that is small, 1 unit by 1 unit is this type of tile. I need one here, I need a third one, and I need a fourth one. And then I'm going to grab the piece that I created here, just this. This is the rectangle whose area is the product x plus 1 by x plus 4. So what you will draw on your paper is that image right here. Draw this. Now, some people have a hard time drawing this. I'm going to help you figure out how to do that. You could start with a whole rectangle and then cut it up like you're cutting a cake. So here's one row, and then I need 4 rows here. Whoa. So here's my x squared, here's my x, 1, 1, 1, 1. And then you can put the x plus 1 on the outside and the x plus 4 on the outside. That's how I would draw it quickly. I just do it like I'm cutting up a cake. Now, I'm going to go ahead and keep mine. You can draw your own on your paper right now. And then I want you to label this x plus 4 and this x plus 1, because it's x this way plus 1 that way. And below it, you're going to write x plus 1 times x plus 4 is equal to. So this is called a product. It's the product of length times width. And what we want to put here is the sum of all the parts. All right, so let's summarize what we got. I see an x squared plus 1, 2, 3, 4, 5 x's plus 1, 2, 3, 4, 4 unit tiles. A complete answer for all of this math, a complete answer. Let me kind of clear up some of these circles so we have a nice pretty picture. All right, close enough. A complete answer has all of this stuff. I want that. I want your composite rectangle with a length and a width showing and all the labels, everything. And then I want the product equal the sum. The answer we are looking for to this problem is right here. It's this sum, but I want all of this to show it. Okay, let's do one more of these. I'm going to go ahead and put that away here. Okay, so the next problem we're going to do comes from, I'm going to sneeze here. This is problem A on your worksheet on the WR70. On WR70 worksheet. Looks something like this. Multiply x plus 5 by x plus 3. All right, so we're going to go up here into our algebra tiles. I'm going to put my x plus 5. 1, 2, 3, 4, 5. Let me fix that a little bit. There we go. And we're going to put our x plus 3. Got to turn it. Ooh, not that. This. There we go. Okay, x plus 3 will go here. 1, 2, and 3. And then we're going to fill in this whole area. So I need a long by long rectangle, an x by x rectangle. That would be this. I need an x by 1. So that's going to give me one of those. Actually, I need 3 of those. 2 and then 3. And then down here, I have long, short, x1. X by 1 would be this way. And I need 5 of those. Let me copy paste. And we'll put them all where they belong. 1, 2, 3, 4. And then in here, I need a whole bunch of those little unit tiles because in there, I've got 1 by 1. See this area? Length is 1, the width is 1. There's a little tiny one right here, so I need 15 of these. And I'm actually going to do this. I'm going to take 2. I'm going to take 3, 4, 5. And if you select it and Control C, Control V, Control V, you can get your 15 really quickly and then just park them right where they belong here. All right. Now I'm going to take that piece out so I can look at it. That's what you are going to draw for your work. And on top of this drawing, I want you to put x plus 3, and x plus 5. And then you're going to write the following. X plus 5 times x plus 3 equals. I see an x squared plus 1, 2, 3, 4, 5, 6, 7, 8 x's plus 3, 6, 9, 12, 15 plus 15. This is my answer right here. I want the whole thing though. When you draw your answer, I want all of this in your answer. I would like you to do that for the rest of the problems, B, C, D, E, and F. I will give you a couple of pointers. When you do problem, I think it was like, let's say D. When you do problem D, when they ask you to do x times 2x plus 1, 2x plus 1 is 2x's plus 1 this way. This x is just an x. There's nothing here. See how it's plus 0? So when you go to fill in this spot, you can put in an x squared tile. You can put another x squared tile. And then this is a 1 by x tile, so that would fill in here. And then you can write your answer because this is the entire product. X times 2x plus 1 equals this stuff. Now, I'm not going to write it down. I want you to do it when you get there. We will check back at the end of this lesson and we will go over these answers with you. Anyway, that's it for this amount of time that we have. Thank you for listening and get to work on the rest of WR70. And then remember, after you finish WR70, you're doing 75 through 80 in your notebook, taking photographs of it and uploading it to our assignment. Thanks for listening.